question 5 and 6?
Yes, please.
Very good. 5 and 6 from quiz chapter 3. Okay. Let's see if I can get there. 5. I'm assuming they're similar. If they're not, you tell me.
Yeah, this is similar to.
Okay. So find the sample variance and standard deviation. Okay. So remember what we did last time. So we click on, so if it's a sample, because we're talking about the sample, right? Remember, we are dividing by n minus 1. Okay. So it has to be the larger number. But we have an option that actually you did. One of you showed me yesterday, not yesterday, Monday. And when we go to stats and summary stats and the column, of course, so there was an option, coefficient, no, I don't want that. Unadjusted standard deviation. So because it's the sample, if it were the population, I would not have used the unadjusted.
Okay.
For the
Hold on. So the standard deviation and the standard, okay, so these are the ones that we have to use. Okay? The unadjusted ones are for the population. Okay. So we can look at all. Why not? Let's look at all. I didn't mean that. And that's another way of comparing. So definitely, the bigger is the one that we want. The smaller will be for the population. So the variance is 51 versus 41, 40.8. This is for the population because it's not adjusted, and this is for the sample. The sample will always have more variation and bigger standard deviation than the population because we divide by n in the population total number, but we divide by n minus 1 when we determine the standard deviation and the variance for a sample. So I'm going to write them down. So the variance, which is S squared for the sample, 51, and the standard deviation, which is S, 7.1414284. Okay, let's see here. So they want,
I think that's what I was confused on. I don't know what it's asking.
So they did want both.
Okay.
Okay, so so I'm going to copy those two. So sigma squared, 40.8, S squared. So the variance and the standard deviation, sigma squared and sigma, not sigma squared. Okay, sigma squared, the variance 40.8, and sigma is 6.384878. Okay, so now, where am I? Where did it go? Here it is. Okay, so they want the S squared, so choose the correct answer below because it's the sample. So we did an example like this in class last time. So S squared, it will be 51. And then S will be, let's see how many, round to 1 decimal place. So I get 7.1.
So how do you know if they're asking for the sample variance or the standard deviation?
Very good question. It's right here.
But it says and standard deviation.
Yeah, but that's
I already did this. Sorry.
But that is a standard deviation is the square root of the variance.
Okay.
It has nothing to do with sigma or sigma squared. So this is for the population, this is for the population. This is for the sample, this is for the sample. We're talking about a sample. You cannot fill this in.
I see. Okay, that makes sense now.
Okay? So sigma, so let me stop sharing. 1 second. I wrote them here. So these notation S squared and S for the sample. And these are the parameters. So this is for the population. So I copied sigma squared and sigma. So for the population, we use sigma and sigma squared, standard deviation variance. For the samples, S and S squared, standard deviation variance. Emily, I'm sorry. Forgive me, I interrupted you. I'm ready.
Oh no, I was just gonna say I did this quiz on Sunday already. I got a 10 out of 10 doing it. But yeah, I just got the S value and then I just put it in the square. I just squared it on the calculator. I do all of my work mostly on my TA84.
That's
and
fine.
I just got the S value.
That's
and
fine, but
put it
it's
in
that's
the
perfect.
online.
That's very convenient. I showed, if you remember, I showed last time with the calculator to show the difference between S and sigma. Very good. Okay, back to the other problem. I think this was 5. Is it it?
Can we also look at 6 as well?
Yes, but does it have another part? I was asking.
Oh, I think that's it.
Okay. Okay, so now this is 6, right? Okay. Sorry, guys, you're always in the way. I'm kidding. Heights of men on a baseball team have a bell-shaped distribution. Nice, with a mean. Okay, so here's how I write it in my notes. So height is approximately normal with a mean of, let me see again, 181, and the standard deviation 9. Please get used to this notation. Very important. I'm going to stop sharing in a second. Use the empirical rule. Using the empirical rule, what is the approximate percentage of the men between the following values? Okay, so I have 163, 199, and 154, 208. Perfect. So let me stop sharing. Perfect. Okay, so now remember we have the empirical rule says 68%, 95%, and 99.7%. This one is plus or minus x bar plus or minus 1 standard deviation. This one is x bar plus or minus 2 standard deviation. And this one is x bar plus or minus 3 standard deviation. So I have the mean and I have, so this is x bar. For such a distribution, I should have considered it mu. But it's the same for this problem. So this is basically mu and this is sigma. But we can consider this notation is the same for this particular example because they are the same. I don't have a sample. I'm really given mu and sigma. So if you want, this will be mu plus or minus sigma, mu plus or minus 2 sigma, and mu plus or minus 3 sigma. Okay, so now I have to calculate. So I have 181 minus 9, 181 plus 9. That will be the interval for 68%. 181 minus 2 times 9 and 181 plus 2 times 9, 18, will be the 95%. And then 181 minus 3 times 9, which is 27, and 181 plus 27 will be the last one. So what do I have here is 181 plus, minus 9 is 172, and this is 190. So this is not what they're asking. So this will be the first one. So minus 181 minus 18 is 163, and 181 plus 18 is 199. So obviously this is the first one that they're asking. So this is the 95%. Is this okay, everyone?
Yes. Thank you.
Do I have to do the last one?
No.
Okay, perfect. Other questions for me? Anything else?
That's all that I had.
Okay, very good. Anyone else? Other questions?
No, thank you.
Okay, so in that case, we will start chapter 4. So that's my page 2 and chapter 4. We're going to talk about relation between two variables. In other words, not just any two variables, but two variables that are collected on the same person or on the same individual. On the same individual, and they create an ordered pair. So here's an example before I already have one ready for you in a minute. But let me just give you another just simple example. Let's say I have 20 students in my class, and I would measure on each and every one of you your height and let's say blood pressure. So let's say I get one person with 5'5" and the blood pressure 130. I create the first ordered pair, 5'5", 130. Let's say I move on to the next and I have 5 and 100. So student number 2 has height of 5 feet and blood pressure 100. So this is the next ordered pair, 5, 100. What do I do with all these? First of all, I establish which one I want to consider the x variable, or sometimes I have to consider the x variable. So let's say the height and the blood pressure. So in my example, height is the independent. Also in statistics is called the explanatory. It explains this. It's the independent, explanatory variable. So this is the dependent variable. Independent, dependent. But also called in statistics response variable. So the x-axis, I consider the explanatory variable to be the height, and the response of the blood pressure, in other words, the response variable or blood pressure or the dependent variable is the y variable. So let's suppose I plot everything I get, all the ordered pairs. I have 20 ordered pairs. I measure every one of you, their height and blood pressure. And then I create what is called a scatter diagram. Let's suppose the scatter diagram looks like this. These are my 20 points, or the pairs. And now I'm asking you, do you think there is any relationship, any association between height and blood pressure if this is the graph called scatter diagram? No. No. No relation. It's all over the place. What if when I plot those 20 points, I get something like this?
The relationship would be the taller they are, the higher the blood pressure.
Excellent. Linear with a positive slope. Awesome. What about this? What if I plot them and I get this?
Would that be linear but with a positive and negative slope?
Careful.
Oh, bell-shaped.
Quadratic. And we will not discuss this one. We will look at this, or either a positive slope or a negative slope. We can discuss this, but not in this course. So either with a negative slope or a positive slope, or something like this that does not create, it does not appear to be the two variables that do not appear to be associated in any way. So here are some examples for you. I'm going to post this also. Response and explanatory, linear, positive slope, negative slope, nonlinear, quadratic or nonlinear, nonlinear, no relation. whatsoever. Okay, now I would like us, I already entered, there are only 12 observations, so let's go to StatCrunch and create our first scatter plot. Okay. I did enter my data, so I don't waste your time. Okay, we'll get to the x variable. It's the depth at which drills begins. So I entitled it depth. Depth. So I'm going to dictate when you are ready.